Hello everyone, and welcome to today's chem lesson. Today we are going to dive into this topic of naming ionic compounds. We know already that when you make a compound, you get something that has a whole different set of properties than the elements that make it. We talked about that the other day with sodium and chlorine, a explosive metal, a poisonous gas, a crystal that you put on your food to make it taste better. And so we need a way to talk about the compound made from sodium and chlorine without confusing it with sodium and chlorine separately. And so the easy solution here is that we're going to name compounds differently than we talk about the individual elements. We have sodium, we have chlorine, but when they come together we get a different thing, sodium chloride. Now the naming convention here, the first step, the foundation for this, is the fact that the first ion is always positive and the second ion is always negative. If you look back at any of the things that we've done so far, it's always the positive ion before the negative ion. That's just the way it works. And when we're naming a compound, the positive ion keeps its name. So for NaCl, we're going to keep sodium as the start of the name, and the negative ion has the ending of its name replaced with "ide." So chlorine becomes chloride. And when we put those pieces together, we get sodium chloride. And we know that this now, with the changed ending here, is referring to the combination, the compound made from sodium and chlorine, and not sodium and chlorine apart. And that's the foundation for how we're going to name compounds, especially, or specifically, ionic compounds. Covalent compounds get a whole different naming convention, but we'll get there when we get there. So the positive ion, the first ion, keeps its name. The second ion, the negative ion, has its ending changed to "ide." Right? Chlorine becomes chloride, oxygen becomes oxide, sulfur becomes sulfide, so on and so forth. But what if we have two different compounds made from the same two elements? Both of these things would have the same name under this system, even though we have two different compounds here. And we don't like that. We don't want that. We don't want two different things to have the same name. We would much rather have two different names because they are two different things. And that's actually going to lead us to start talking about the idea of multiple different oxidation states. And we're finally going to talk about this number in the upper right-hand corner of the periodic table cells. These numbers in the upper right-hand corner are the oxidation states. Right, the same way the key points that out, that these are the oxidation states. What that means is that these are the possible charges for this element. it lets us know that magnesium can only be a +2. It can only ever lose 2 electrons. Which makes sense with what we know about valence electrons. On the other hand, something like copper has the ability to lose 1 electron or 2 electrons. The losing 1 electron makes sense according to what we know about valence electrons, and the +2, right, the ability to lose 2 electrons, comes from the fact that the quantum mechanical model is a thing that exists. Right? We don't have the whole picture because we're not looking at the quantum mechanical model, but that's fine. We don't need the whole picture for what we're going to do. So looking at this, we know that copper has 2 different possible charges. You can have copper with a +1 charge, or you could have copper with a +2 charge. And like we said a second ago, if I combine those with chlorine, I get 2 different compounds. But we don't have any way of telling the difference between this copper chloride and this copper chloride. And we need a way to be able to tell the difference between these 2 things because they are 2 different compounds. Even though it is a slight difference, it is an important difference. When we look at molecules on any scale, really, the tiniest difference changes what they do. And so, what we end up doing, in order to tell the difference between these 2 things, is we use Roman numerals. When we talk about copper +2, we say copper 2 chloride. These Roman numerals are going to represent the positive charge of our ions. And how do we correctly identify the Roman numeral? How do we correctly identify what the positive charge is going to be every time? Well, we use something called the Criss-Cross Method, which is what we're going to talk about for the rest of our lesson today. Now, the Criss-Cross Method has a number of steps, and we're going to slowly go through them and do some examples. Right, our first set of examples is going to be copper +1 chloride and copper +2 chloride. We're going to show how we use the Criss-Cross Method to differentiate between these 2 things. So, here we have our 2 compounds here, and we know that they should have 2 different names because they are 2 different compounds. And here we have the steps of our Criss-Cross Method. We're going to walk through them one at a time, top to bottom, and then again, top to bottom, to make sure that we've got a handle on what we're doing. And I'm going to color code with these rainbow of colors down here so we see what is happening in every step. The first thing we're going to do when we look at a compound and we want to get the name of that compound is we are going to assign 1s to things that don't have any numbers. Right, so here, copper chloride, CuCl, we don't have any numbers here. We don't have any subscripts. And so what we're going to do is we are going to assign our 1s. A 1 and a 1. 1 copper, 1 chlorine. And that's the whole first step. Our second step is to crisscross, right? So the crisscross method, we're going to have to crisscross somewhere. And the way we are going to crisscross is we are going to take the number from one element and bring it up and over to the other element. Right, so I'm going to bring the 1 from copper up and over to chlorine. I'm going to bring the 1 from chlorine up and over to the copper. Which is going to leave me with something that looks a little bit like this. Then I am going to assign charge. We know that the way every compound is written, the first ion is positive and the second ion is negative. In the next step, the next thing we need to do is check the periodic table. We need to know that these charges are possible. And so, we're going to pull up our periodic table and we are going to come over here and we are going to find copper and chlorine. Here's copper. Does copper have a +1 charge? Yes, it does. Right, that +1 is possible, and so we're going to mark it as possible. Right, check the periodic table. Does copper have a +1? Check mark. Yes, it does have a +1. Does chlorine have a -1? Let's check the periodic table. Chlorine has a bunch of oxidation states, but a -1 is possible here. It is a thing that chlorine has open for it. And so, since it has a -1, we get to put a check mark here. Now, since both of these check, right, since both of these match, we can go on and get our name. And our name is going to follow the convention that we said before. First element keeps its name. Second element gets its name changed to end with "-ide". But for our name, we want to be able to tell the difference between these two things. We're going to include the Roman numeral, copper 1 chloride. Now, copper 1 chloride comes from the fact that it is copper +1. Right? The Roman numeral matches the charge of the positive ion. So because this is a 1, this is also a 1. And we only need to include Roman numerals for elements that have multiple possible positive charges. When we're talking about cobalt, which has a +2 or a +3, we need to include that Roman numeral. But when we talk about something like zinc, zinc can only ever be +2. We don't need to write a Roman numeral here, because zinc only has one positive charge. Something like nickel, 2 different charges. We need to include the Roman numeral to tell, are we talking about nickel +2 or nickel +3? Something like gallium. We don't need a Roman numeral because it only has one positive charge. Something like manganese definitely needs a Roman numeral so we can tell the difference between the 4 different charges. And yes, so the Roman numeral always matches the positive charge. Whatever number you get here, right, this is a 1, so this is a 1. Right, there's also a question about what if you check the periodic table and it doesn't match up, we're going to get to that in a minute. Right, let's look at copper Cl2, right? Copper chloride again. Again, our first step is to assign our ones. We only need to put one in here. Boop. Because the chlorine already has a number. Then we are going to move and go and do our crisscross, where we are going to take the 1 from the copper and bring it up and over to the chlorine, and the 2 from the chlorine and bring it up and over to the copper. It's going to give us something that looks like this. We're going to assign our charge. We know that the first ion is always positive and the second ion is always negative. We're going to check the periodic table. Does copper have a +2? Let's check. Copper has a +2, so that's good. Does chlorine have a -1? We know already, because we just checked it, that chlorine has a -1, but just to be safe, we double check again. And so again, we get two things that match the periodic table. Check, check. Because those both match, we can move on to our name. Copper for the first positive ion. Chlorine becomes chloride. And we put that Roman numeral, which is going to represent the number, right? The same number of the positive charge. Because it's copper +2, we are going to put a 2 for our Roman numeral. The Roman numeral is the positive charge. Now, what happens if we check the periodic table and it's not a match? What happens if we don't put check marks here in this spot? Well, we have to change something. And so we're going to talk through an example of that. Right? All these other steps are straightforward. Right? Assigning ones, if there's no number, you put a 1 there. Crisscrossing, you bring the numbers up and across. Assigning charge, first is positive, second is negative. The only time you can get something that doesn't match up, right, the only thing that gets a hitch in this step is checking the periodic table. So let's look at something like this. CuO. Copper and oxygen. Let's run through our steps, right? First step, we are assigning our ones. We are going to put a 1 for our copper, a 1 for our oxygen, because neither one of those has numbers there. Then, that's going to bring us here with our 1 and our 1, and we are going to crisscross those numbers. We're going to bring the 1 up and over to the copper, and this 1 is going to go up and over to the oxygen. Then we are going to assign our charges. Right, copper, our first element is always positive and our second is always negative. Right, then we're going to check the periodic table, which we're going to do in a second, because that's actually a really interesting question that just popped up in the chat. Does the negative charge ever matter? The answer there is no. You never, ever need to worry about the negative charge. It never comes up in the name. And the reason for that is because the only element that has multiple negative charges is nitrogen. And the non-3 versions, right, let me pull back up the periodic table. The things that are not -3, right? This -2 and this -1 are so very rare that we basically just ignore them. And so there's never going to be a set of choices for you for a negative oxidation state, right? Everything that has a negative oxidation state has only one negative option. And so it never comes up. But we're not talking about nitrogen right now. We're looking at copper and oxygen. Right, we're checking the periodic table. Does copper have a +1 option? Yes, it does. Does oxygen have a -1 option? No, it does not. So here we get check, wrong color, we get check and X. And that's not good. We don't want this X there. We need both charges to match the periodic table in order for us to continue. And when you hit a situation like this, the way you're going to fix it, the way you're going to get both of these to be checks, is by multiplying both charges by the same amount so that they match the periodic table. Right? That means you're either going to double them both or triple them both to make them match the periodic table. So oxygen doesn't have a -1. What does it have? Let's take a closer look. Oxygen has a -2. So I would need to double the -1 to make it a -2. And if I'm doubling the charge on the oxygen, I also need to double the charge of the copper. Can I do that for copper? Can I take a +1 and double it? Look, I sure can. Copper has a +2. And so because these don't match, we are going to double the charges, right? Meaning we're going to put a 2 here and a 2 here. And then we're going to check again. Copper has a +2. Oxygen has a -2. We're good now, right? Both of these have become checks. We can move on and put our name down. Copper. Oxygen becomes oxide. And our Roman numeral here is going to match the positive charge. Right? We need a Roman numeral because copper is one of the elements that has multiple oxidation states. Right? Copper has 2 different things to choose from. And so we need to mark that. We need to put a Roman numeral. The question here, the charge stays the same. We have to adjust the charges to make them match the table, but whatever we do to one charge, we must do to the other. Alright, so we had to double our -1 to make it a -2. So we had to double our +1 to make it a +2. But then after that, after we've made that adjustment to make them both match the table, we're done messing with charges. We're done changing charges. And so we make our adjustment, and then we get our name, copper 2 oxide. So we're not actually, right, if we needed it to be a positive charge, we would multiply by a negative charge. We never need to change the sign. The sign is always correct. Right, the first ion is always positive, the second ion is always negative. But in situations where, like this one here, they don't both match the table, right, this matches, this does not, we're going to either double the numbers, triple the numbers, quadruple the numbers, right, the value, not the sign. The sign is going to stay exactly the same. And so here, copper has a +1, so that checks out, but oxygen can only be -2. And so I must double both of these charges. Correct. I need to double it because oxygen cannot be a -1. Right? The periodic table says it can only be a -2. It doesn't have a -1 listed here. So I need to double it. But if I double one, I must double the other. Whatever I do to change one of them, I must do to change the other one as well. And that makes both charges match the periodic table, which brings us to our name of copper-2 chloride. Are there situations where both charges don't match? Totally, 100%. The same thing applies. Fixing one will fix the other. Right? If copper didn't have a +1, it would have had a +2 to make this work. The compound doesn't work. It will not exist if both charges don't match the periodic table. Right? If you can't get both charges to match the periodic table, right? Doubling, tripling, quadrupling will make it match, even if you have to do that to both of them. Let's look at some practice for us to do on our own here. Here we have a big list of compounds that need names. Can you name these compounds? I'm going to give you about 1.5 minutes of silence. I know you will not be able to do all of them in 1.5 minutes, but we could always come back to these later. And so let's look at some answers here. If you still want some more time, please feel free to pause the video, keep working. But our answers are going to go on the screen right about now. So, remember that you only need a Roman numeral if your positive ion has multiple options, magnesium can only ever be +2, so we don't need a Roman numeral for it. Barium can only ever be +2, so we don't need a Roman numeral for it. Lithium can only ever be +1, so we don't need a Roman numeral for it. Right? Specifically, cases where both charges don't match. We've got a couple on here. Both don't match. Both don't match. There's another one. This one. Both don't match. Both don't match. So for those, you would need to adjust both of the charges by the same amount to make them match the table. I have another set of practice problems here that we're not going to do on screen together, but these, besides this one that I already did with you, this set is a set of all elements that need Roman numerals. So this is focusing specifically on correctly identifying and placing Roman numerals. So here I'm going to give about 30 to 40 seconds before I show the answer. This is specifically for you to pause and to work on when you come back to rewatch the video, or if you're watching the video after it's going live. And so, the answers to this set of practice problems are right here. Again, meant to be done after this video goes live, so if you come back to review, this is a practice problem set that you should be looking at. And we're going to continue with this concept next time, but for now, I'm going to transition us over to our Zoom meeting for questions, comments, concerns, and attendance. And I will see you there.